Okay, in this video, we're gonna try to prove that if we are given that cosine alpha is a over b plus c, and cosine beta is b over a plus c, and cosine gamma is c over a plus b, we want to prove that tangent squared of alpha over 2 plus tangent squared of beta over 2 plus tangent squared of gamma over 2 is 1. Okay, for those of you who want to prove this result, note that you have to relate tangent to the cosine. But remember here you have only tangent of alpha over 2, and you are given that only the alpha or beta or gamma. So you have to relate the half angle to this one. Also, your result must be independent from these numbers a, b, and c. Okay? So if you want to go ahead and try to do it by yourself, stop the video and start doing it. Otherwise, we're going to give a hint in the start. Okay, let's see the hint that we can get. So the hint here is that we can prove that 1 over cosine squared of alpha is 1 plus tangent squared of alpha. So this is a good start here, but it's not giving us the alpha over 2, the beta over 2, the gamma over 2. Another hint that we can get is that cosine alpha is 2 cosine squared of alpha minus 1. Okay? Alpha over 2 here, sorry. Alpha over 2, sorry. Because you remember that we have cosine of alpha is cosine alpha over 2 plus alpha over 2. And we apply our rule. Cosine alpha over 2 times cosine alpha over 2 minus sine alpha over 2 sine alpha over 2, and this is cosine alpha over 2 squared minus 1 plus cosine squared alpha over 2, because this is sine squared, and we get 2 cosine squared of alpha over 2 minus 1. So we prove this result here. This one here, we can prove it as well. So an easy way is to write, so we have 1 over cosine squared of alpha. We can write 1 as cosine squared plus sine squared. So we have cosine squared of alpha plus sine squared of alpha over cosine squared of alpha, because this is 1. And once we do that, we have cosine over cosine is just 1 plus sine squared over cosine squared. That's the definition of tangent. That means we have tangent squared. So this one gives us the result. Okay, so now relate this property here to this one here. So here, so what's 1 over cosine squared of alpha over 2? Okay, so if we relate this one, make this one half angle related to this one, and you can start seeing the solution of the problem. Want to stop here and start doing it if you want to. Okay, otherwise let's solve this one. Okay, so given that we have all this information, we want to solve. So the first thing that we want to do is that we want to write this one in function of alpha over 2. Okay, so once we do that, so we have, if we switch here to alpha over 2, we have tangent squared of alpha over 2, sorry, plus 1 is 1 over cosine squared of alpha over 2. So if I put the minus 1 here, I get tangent squared of alpha over 2 is 1 over cosine squared of alpha over 2 minus 1, which I can write as 1 minus cosine squared of alpha over 2 over cosine squared of alpha over 2. Okay, but the problem here, I don't have in my problem cosine of alpha over 2. So now I have this one. I need to keep this one on the side. Now with this formula here, I can get the alpha. So from here, so I have the squared is cosine squared. Solve here. Cosine squared of alpha over 2 is just 1 plus cosine alpha over 2. So this is giving me 1 minus cosine alpha plus 1 over 2. So this is the same thing, 1 plus cosine alpha, everything is over 2. So when I simplify here, I get 1 minus cosine alpha over 1 plus cosine alpha. I had to eliminate the 2 from the top and the bottom. Therefore, I have a result that can help me solve this problem. Okay, so tangent squared of alpha over 2 is just this one. So now let's compute it in terms of the problem. We have cosine alpha is just a over b plus c. So here we have this result. So tangent squared of alpha over 2 is 1 minus cosine alpha over 1 plus cosine alpha. So this is 1 minus a over b plus c over 1 plus a over b plus c. If I do the simplification, I get b plus c minus a over b plus c plus a after simplification from top and bottom by b plus c. For the same thing here, tangent squared of beta over 2 is 1 minus cosine beta over 1 plus cosine beta. So it's 1 minus b over a plus c over 1 plus b over a plus c. It will give me a plus c minus b over a plus b plus c. Okay. And the final result is tangent squared of gamma over 2. It's gonna give me the same thing. It's gonna give me, so here I have b plus c minus a plus c minus b. The final one left is b plus a minus c. So it's b plus c minus b plus a minus c over a plus b plus c. Okay, now if I add these three, what do I get? So I have the same denominator, a plus b plus c, in all of them. So on top, what do I have? So doing this addition, so let's call this sum here, let's call it a. So a is gonna be, the first one here is b plus c minus a, b plus c minus a. The second one is plus a plus c minus b. The last one is plus b plus a minus c over a plus b plus c. So I have some cancellation to make. Okay, so here this a will go this a, this b will go this b, and this c will go with this c. So all I'm left with is c plus b plus a over a plus b plus c, and that's 1. Okay, and that's 1. That's all I need. So I found my result. Okay, so it's a bit messy, but you get the idea here. This is the most important thing. The rest is just algebra and computing the sum. Okay, so when you do that, you're gonna get, it's like some cyclic symmetric. So here alpha is b plus c minus a, beta is a plus c minus b, gamma is b plus a minus c over a plus b plus c. All of them, they have the same denominator. Okay, so once we multiply, we get, once we do the addition, we get in fact 2b plus 2b plus 2c minus a minus b minus c, which is giving us a plus b plus c over a plus b plus c, which is 1. And this proves our result. The most important thing is relate these angles here with what you need to compute. And I think this ends our video. Please share, like, comment, and subscribe. Thank you very much.